This video demonstrates how to model a simple pendulum. We'll create a support, Revolute joint, and then we'll create the pendulum. We'll then perturb the pendulum by setting a joint angle which is other than 0, and then we'll run the simulation so that the pendulum will swing freely. So we'll start by creating the stand. Cuboid. Next, we'll add, we'll rename this to stand. Next, we'll add a joint. In this case, we want a Revolute joint. Let's rename that to joint. Now the joint is buried inside the cube. So what we'll do is we'll move it up, translate along z-axis. We'll move it out. Yeah, we can change the look of it by clicking on joint twice. Change the diameter to 0.1, and that looks a little bit better. Okay, now what we need to do is we need to make the joint as a child of stand. So we click on joint to press the keyboard key to hold it and then dump it onto the stand, which will effectively make it a child of the stand, or the word stand is the parent of joint. Okay, now what we'll do is we will move this up and rotate it by 90 degrees so that it's ready for us to add the pendulum. So first I'll translate along the z-axis. So we'll choose the stand and then we'll translate along z-axis. So now you see that when I move the stand, the joint moves with it. Now I need to rotate the stand by 90 degrees so that the pendulum will be in the right orientation. So rotate. This looks okay, I think. Rotate about y-axis. Okay, so when I rotate, it actually goes back to the floor, so we need to move it again. So translate along Z. And maybe we can just translate along X2. Okay, so we have the stand, we have the joint. Let's add another body, the pendulum. So in this case, I'll use a cuboid with a length of 0.5. Okay, now I need to move this right near the joint. So what I'll do is I'll first make it a child of joint. Next, I will do translate, position. And so it's a neat trick to quickly align the joint close to the cuboid. So set the position using the keypad, say parent frame, and this basically tells where the x, y, z coordinate of the geometric center is with respect to the joint. So let's just set that to 0, 0, 0. And so now you see that it's lined up nicely. Now all I need to do is move this up. So I can here make a guess that I need to move 0.25 meters because this length of the whole cuboid is 0.5 meters in one of the 3 directions. I'm just going to guess here 0.25. Okay, that moved in the other way, so it means it should minus 2. Okay, this looks good. Let me zoom out. And then let me move that in the middle. And now I'm ready to simulate it. So what I'm going to do is I'm just going to press simulate, and you can see that the whole thing falls. And that's because I've made the stand as a free floating body. I need to change that. So what I can do is I'll go to stand, I'll double click, I'll say show dynamic properties, and I want it to be not dynamic. So it'll be static, not move. And I can now run this to see that nothing moves, and it doesn't move because the pendulum is right vertical. So what I can do is I can perturb the angle of the pendulum by a few degrees. So let's go to joint. Here we'll set it to, so right now it's set at 0. Let's set it to 2 degrees. Enter, stop, and then, so you can see that it runs, it actually spins at a crazy pace. If you want to slow it down, what you need to do is stop this, say real time, and run. Okay, so now it's more uh, nicer in terms of animation speed, and it spins like a pendulum. That's it.